Welcome back to another exciting lesson in our IoT series. Today, we're moving to the second module. We are going to explore the layers of IoT architecture, the structured framework that organizes how components within an IoT system interact. This architecture is not just crucial for the technology's functionality. It's also the backbone of creating efficient, scalable, and secure IoT solutions. Let's dive in and break down these layers one by one. So, let us put all minds together. Starting at the base, we have the perception layer. This is where our IoT system begins to sense the world. It includes sensors and actuators that interact directly with the environment. Here, data is collected through sensors, while actuators perform physical actions based on this data. It's the foundation of data collection in IoT. Next up is the network layer. This layer is all about transmission, taking the data from our sensors and sending it to other devices, servers, or the cloud. It uses a range of connectivity protocols like Wi-Fi, Bluetooth, and cellular networks to ensure that data moves securely and swiftly. The third layer is the middleware layer. Think of it as the bridge between raw data and practical use. This layer handles device management, database management, and data analytics. It processes the data to make it useful for decision-making and operational efficiencies. As we ascend, we reach the application layer. This is where the processed data comes to life for users. Applications here allow for data visualization, send notifications, and control devices based on the analyzed data. It's what the end users interact with daily, making the IoT tangible and functional. Finally, we have the business layer. Although not always labeled separately, this layer oversees the entire IoT system. It manages applications, business models, and ensures that the IoT setup aligns perfectly with organizational goals. It's about turning technology into business value. Together, these layers create a comprehensive IoT system, from gathering and sending data to making strategic business decisions. This architecture supports a vast array of functionalities in IoT applications, from smart homes to complex industrial systems. Understanding the structure and function of these layers is crucial for anyone involved in IoT. They ensure our systems are scalable, secure, and private, compliant with regulations like GDPR. In our next lessons, we'll dive deeper into each layer, exploring their technologies, protocols, and the challenges they face. Okay, let us move on exploring the lifeline of IoT systems connectivity technologies. Understanding how devices communicate is crucial, and choosing the right technology can make or break the efficiency of an IoT system. Let's get into the details of Wi-Fi, Bluetooth, Zigbee, and 5G to see which fits best for different IoT scenarios. This is actually another interesting part of this course. First up, Wi-Fi. Known for its high-speed internet and network connections, Wi-Fi is ubiquitous in both home and commercial environments. It's perfect for devices that need to transfer large amounts of data, like video cameras or desktops. Despite its extensive range and speed, it's not without drawbacks, including significant power consumption and susceptibility to interference in crowded spaces. Moving to Bluetooth, a champion of short-range communication. This technology is a go-to for devices that don't require high data rates but benefit from low power consumption. Bluetooth shines in applications like wearable health monitors and smart home devices, helping them communicate efficiently without draining battery life. However, its limited range and slower data speeds might be a constraint for more demanding tasks. Next, we have Zigbee. Utilizing low-power digital radios, Zigbee is fantastic for creating mesh networks that enable device-to-device communication over extended areas, making it ideal for smart home automation. Devices on a Zigbee network can pass data along to each other, spreading coverage throughout a space. While it supports efficient, low data transmission, its lower speed limits its use in high-speed applications. And then there's 5G. The newest player in the field, 5G is set to revolutionize IoT with its high bandwidth and ultra-low latency. This makes it perfect for industrial applications where rapid, large-scale communication is critical, think automated factories and smart cities. Yet, the cost and current availability of 5G infrastructure can be a barrier, especially outside urban areas. When choosing the right connectivity technology for your IoT project, consider factors like range, data needs, power consumption, and the environment. Also, think about how these technologies can integrate into a multi-technology environment to harness each one's strengths. In summary, each connectivity option offers unique advantages and comes with its own set of limitations. Your choice will depend on the specific requirements of your IoT application. Are we good on that? Okay, let us move on. In this lesson, we're looking into the essential hardware components that make the Internet of Things function seamlessly. We'll focus on sensors, devices, and gateways, exploring how they gather data, process it, and communicate within an IoT ecosystem. Let's get started with understanding these critical components that drive intelligent decision-making in IoT systems. First, let's talk about sensors, the front line of any IoT system. Sensors detect environmental changes or measure physical properties like temperature, humidity, and motion. They are the initial data collectors in IoT, turning real-world phenomena into digital data. There are several types of sensors used in IoT. Environmental sensors, these measure elements such as temperature, air quality, and water quality. Motion sensors, these detect movement and orientation. Proximity sensors, these measure the distance between the sensor and an object. Other sensors, including light sensors and pressure sensors, which have specialized applications. Sensors find applications in numerous fields, from automating your home HVAC systems to monitoring equipment in factories and tracking health data via wearable technology. Each type plays a pivotal role in collecting precise data for further processing. Next, we have IoT devices, which include microcontrollers and microprocessors. These devices take the data from sensors, process it, and execute decisions. They are the brains behind the operation, where the logic happens. IoT devices vary widely. Microcontrollers, small but powerful, they are integrated circuits that can process sensor data and control other devices. System on a chip, SoC, these integrate all components of a computer into a single chip, which is ideal for more complex applications. Developer boards, such as Raspberry Pi and Arduino, these are used extensively for building and prototyping IoT solutions. Finally, gateways. These act as the crucial bridge between local IoT devices and the broader network. Gateways aggregate data from multiple devices, maybe pre-process it, and send it onward, often adding an extra layer of security. In a smart home, a gateway might collect data from sensors and devices like thermostats and cameras, sending it securely to a central service for management. Choosing the right gateway involves considering connectivity options, deployment scale, and specific security needs. Consider a smart factory where sensors monitor equipment performance. Microcontrollers analyze this data to predict maintenance needs, and gateways ensure this data is securely transmitted to management systems for actionable insights. Understanding the types of IoT hardware and their roles within an IoT ecosystem is crucial for designing and deploying effective IoT solutions. In this lesson, we've laid the foundation by exploring sensors, devices, and gateways, all pivotal for successful IoT implementations. Let us quickly look into the brain of the Internet of Things, its software. Just as hardware forms the body of IoT devices, software is the brain that controls operations and communication. This is the final part of this module. Let us pay attention. What do we mean by IoT operating system? IoT operating systems, or OS, are the foundation of any IoT device. These systems are tailored to run efficiently on devices that might have limited processing power and memory, but are still expected to perform optimally. There are several types of IoT operating systems. Real-time operating systems, RTOS, like FreeRTOS and Zephyr, are crucial for applications requiring precise timing and reliability. Embedded Linux is used in more powerful devices, providing extensive functionality and supporting a wide range of connectivity options. Windows 10 IoT Core, tailored by Microsoft for smaller devices, supports universal Windows apps and integrates easily with various services. These operating systems can be found in devices ranging from wearable tech and smart appliances to comprehensive industrial control systems. Each one is chosen based on specific device requirements and application needs. Key players include AWS IoT Core, which allows secure device connection and integrates seamlessly with other AWS services. Google Cloud IoT, a set that supports device management, powerful data analytics, and machine learning. Microsoft Azure IoT, providing extensive management tools and advanced analytics. IBM Watson IoT, known for leveraging cognitive computing to enhance decision-making based on real-time data. These platforms are not just software layers. They are ecosystems that can manage everything from smart city infrastructures to complex industrial systems and healthcare networks. When selecting the right IoT software, consider scalability, security, interoperability, cost, and user-friendliness. Each factor plays a critical role in determining how effectively the IoT system integrates and operates within its intended environment. In conclusion, understanding the different IoT operating systems and platforms is vital for anyone involved in the IoT space. Today, we've covered the essentials that will help you make informed decisions about the right software to power your IoT solutions. Join us next time as we go deeper into the specifics of each platform and explore case studies demonstrating their impact in real-world scenarios. Thanks for watching. Stay tuned for the next module. Do not forget to like, comment, and subscribe to our channel.